All right, so this next tool for finding derivatives called the quotient rule will allow us to find the derivative of things in fraction form right here. So this is the formula. I'll talk through it. I'm actually going to reorganize it a little bit the way I like to think of it. Unlike the product rule, which I'll remind you of the product rule up here, which was a combination of the derivative of each function. So it was like derivative of f times the original other function plus the regular original f times the derivative of the second function. Because it was addition, the order that you did this didn't matter, but with the quotient rule, there's a subtraction in there, so order definitely matters. So this formula is definitely going to be one that you are going to refer back to as you're working through the homework problems on Delta Math, just to remind yourself of what order things go in. So the quotient of the derivative of a quotient of two functions of x. So we're calling the numerator f and we're calling the denominator g of x. The formula is the original g of x, whatever the denominator is, times the derivative of the numerator minus the original numerator times the derivative of the denominator. So right away, this is looking similar to product rule, but there's a minus in front. So this first term and this second term need to stay where they are. The denominator is always just the original denominator squared. I like to think of this a little differently. It's the same thing. I like to just, I have an easier time remembering this way, the derivative of the numerator times the denominator. I don't know why, I just like that better, minus the original numerator times the derivative of the denominator. So I don't know why I like that better, divided by the denominator squared. I think it just, my brain likes that f is the first function both times. But however you want to think of it, this is the exact formula we're going to apply. So let's do a few examples. All right, so first function here, g of x, 5x minus 2 over x squared plus 1. So the derivative of g, derivative of this, going back to our formula, I'm going to refer back to this one. The derivative of the numerator, which in this case is just 5, times the original denominator. So g of x is this denominator. So that would just be x squared plus 1. Then minus the original numerator, so 5x minus 2. Anytime you're writing a quantity with more than one term, you should use these parentheses because we're always multiplying, times the derivative of the original denominator, which in this case would just be 2x. 2x, all over the denominator squared. So that would just be x squared plus 1 squared. Now in terms of simplifying, so we've just applied the formula. Derivative of the numerator times the denominator minus original numerator times derivative of the denominator over denominator squared. Now, all we have to do is simplify. In terms of the denominator, you can always just leave this as a quantity squared. You don't have to multiply that out, but we should definitely distribute and simplify in the numerator. So that would be 5x squared plus 5 minus, I'm going to keep this in parentheses for now because I'm going to distribute this 2x first. So that would be 2x times 5x is 10x squared. 2x times negative 2 is negative 4x. And then I'll distribute x squared plus 1 squared. Then I'll distribute right here and combine like terms. So I'm going to have 5x squared minus 10x squared. So that's a result of negative 5x squared. Negative 5x squared, so I've done those. And then a minus negative 4x, so that's plus 4x. And then plus 5, all over x squared plus 1 squared. So that's it. Really, you don't have to do too much for these. You're just following this exact formula, this pattern here, and then simplify the numerator and you're done. So that's how you apply quotient rule. Let's just do a few more examples. I want you to still see the formula here. Okay, whoops. Okay, so this second one, number 8, x squared minus 2x plus 3. Sorry, I forgot to mention we're still in the 2.3 notes here when I started this. Hopefully you figured that out. All right, f prime. Okay, following our formula here, it's going to be the derivative of the numerator. So that would be, this is what I'm going off of, derivative of the numerator times the denominator. Derivative of my numerator, since we are just applying power rule, would be 2x minus 2 times the denominator, which is x minus 5, minus, now I'm going to do this piece over here, which is the original numerator, 5x minus 2. Nope, that's the wrong problem. Original numerator, x squared minus 2x plus 3 times the derivative of the denominator, which in this case, their derivative of that is just 1, which is nice because then I don't have to multiply this by anything. And then the denominator is my original denominator squared. All right, so as I mentioned, we don't really need to worry too much about the denominator. We're just going to distribute in the numerator where we can, combine like terms, and then we'll have the derivative. So this right here, some of you are used to using area models, which I think is great. So if you did that, it would be 2x minus 2 and x minus 5. So we'd get 2x squared minus 2x minus 10x plus 10. So 2x squared minus 12x plus 10 minus, now we're taking this and distributing it to all three terms. So that's going to be minus x squared plus 2x minus 3 all over x minus 5 squared. And then our final step here is just going to be combine like terms. So we have 2x squared minus x, so that's just 1x squared, negative 12x plus 2x, so that's negative 10x, and 10 minus 3, all over x minus 5 squared. All right, let's turn the page. Two more quick examples with you guys. All right, let's do one involving trig. So looking at number 9, we've got cosine of x divided by x. So in this situation, because I have a quotient of two different functions on x, I will use the product or the quotient rule. So the derivative is the derivative of the numerator, which remember is negative sine of x. Derivative of cosine is negative sine of x times the original denominator minus the derivative of the denominator times the original numerator, or vice versa, however you want to think of that. So cosine of x, the original numerator, times the derivative of the denominator, which is just 1, all divided by denominator squared. So this is convenient because we're pretty much done. The only thing I would do in terms of simplifying is take this x here and move it in front, just so it's not confusing as to am I taking the sine of x or am I taking the sine of x times x. So this is negative x sine of x minus cosine of x all over x squared. So that's it, you guys. Quotient rule is not too bad. I'm not going to go any deeper into it. When you start using quotient rule with roots and fractional exponents, it does get a little more complicated. I just want to keep it simple, expose you to the formula, and get you a little bit of practice with it. I do want to address a couple of situations where just because you're looking at a fraction for your function doesn't mean you have to use the quotient rule. Sometimes if you're clever about it, you can save yourself a little bit of hassle and just use the power rule, because in a situation like this on number 11, what we see is, if we see initially a function in the numerator and a function in the denominator, but this actually simplifies pretty nicely because there's an x in every single term in this whole problem. So this is actually the same as, so by simplifying, I'm basically canceling out x to the first from every single term. And I just covered up my numbers. It would simplify to 2x squared plus 3x. So this simplifies to a function that you can just very easily apply the product rule or power rule to. So this would just be, the derivative would just be 4x plus 3. We would arrive at that derivative if we applied the quotient rule. It would just be a little bit longer of a process. Same with number 12. So you see a fraction, and we could definitely apply the quotient rule here. However, if you notice that there's only an x in the denominator, we can actually rewrite this in the same way we would in the very first section of this chapter, which is rewrite this as 3/2 times x to the -5. So we can just rewrite it this way, then apply the power rule. So we could just bring down the -5, and we would get y prime is -15/2 x to the -6, and then just rewrite it. So this is just a quicker way to get there. If you see a fraction and revert directly to quotient rule, that's fine. You'll always end up at the correct answer, or it's possible to, but sometimes if you rewrite it cleverly, you can just use power rule. So quotient rule is helpful, super helpful in a lot of situations, but sometimes you can rewrite it and use the power rule. So that's it, you guys. I'm going to stop here on quotient rule. There's 5 problems I want you to do on delta math, and just applying this formula. Pay close attention to whether it's asking you to simplify or not. And let me know if you guys have any issues with that. Okie doke.